All right, let's talk about something that pretty much all of us use, but maybe don't fully get. Sunscreen. It's way more than just something you slather on at the beach. If you ask a chemist, they'll tell you it's actually this super sophisticated daily shield. It's like a team of tiny molecular bodyguards standing between your skin and, well, an invisible attacker. So how exactly does this shield work?
Okay, so what's the deal here? Have you ever thought about what it's actually doing on your skin? Is it acting like millions of microscopic mirrors just bouncing all that sunlight away? Or is it more like a sponge, soaking up those harmful rays before they can do any damage? It's a great question, and believe me, the answer is probably not what you're thinking.
So before we can really meet our molecular bodyguards, we've got to understand the enemy they're up against. The sun is blasting out all sorts of ultraviolet or UV radiation. But the two types that actually make it down to Earth, the ones we have to worry about, are UVA and UVB.
Now these two have pretty different jobs. You can think of UVB with a B for burning. These are the rays you feel. They hit the surface of your skin and cause that painful red sunburn. But UVA with an A for aging is way, way sneakier. Get this, UVA rays make up about 95% of the UV radiation that gets to us. They go deeper into the skin, wrecking collagen and causing wrinkles. And, crazy enough, they can pass right through window glass.
Okay, so to protect our DNA from both of these attackers, we've basically got two different teams of molecular bodyguards we can hire. You probably know them as chemical and mineral sunscreens, but let's call them by their code names, the sponge and the shield.
First up, let's meet Team Sponge. These are the chemical filters. They're organic, which just means they're carbon-based molecules. You've probably seen names like avobenzone and oxybenzone on the ingredient list. Their whole strategy isn't to block the attack, but to absorb it.
So how does this microscopic sponge actually pull this off? It's pretty amazing, really. When a UV ray hits one of these molecules, its electrons literally absorb that energy and jump into what chemists call an excited state. But this state is super unstable, so the molecule immediately calms down, and as it does, it releases that energy as a tiny, totally harmless amount of heat. The whole thing happens in a flash, microseconds, and it just keeps repeating over and over. It's like a tiny, powerful energy-converting factory right on your skin.
And then we have Team Shield. These are the physical or mineral blockers, made of inorganic stuff like zinc oxide and titanium dioxide. Now, for decades, the thinking was that these guys just sit on top of your skin and act like a microscopic mirror, literally reflecting and scattering the UV rays away. Simple enough, right?
Well, here's where it gets really interesting. This is a perfect example of how science is always learning new things. It turns out that whole mirror idea, it's only a tiny part of the story. Recent research shows that mineral sunscreens also work mostly by absorbing UV radiation. We're talking up to 95% of it and turning it into heat, just like their chemical cousins. So it turns out the shield is also a sponge.
So the bottom line is that, while both types mostly absorb UV rays, they do have some key differences in how you use them. Chemical filters need, about 15 or 20 minutes to bind to your skin before they start working. Mineral blockers, on the other hand, give you protection right away. And yeah, mineral ones can sometimes leave that whitish look, but they're often a much better bet if you have sensitive skin.
All right, we've met the bodyguards. Now let's talk about how to read their resumes, because that label on the bottle can be confusing. It's time to decode the most common and probably most misunderstood term of all, SPF.
So many of us think that SPF 30 is twice as good as SPF 15, but that's not really how it works. Take a look here. An SPF 15 already blocks about 93% of UVB rays. Bumping up to SPF 30 gets you to 97%. And going all the way up to SPF 50, that gets you to 98%. So that huge jump from 30 to 50 only buys you an extra 1% of protection. It just goes to show you how much you apply is way more important than chasing some crazy high number.
And here it is, maybe the single most important thing you need to know about SPF. It only measures how well you're protected from UVB rays, the burning ones. It tells you absolutely nothing about your protection from those deep-diving, aging UVA rays. And that is why you have to always look for these two little words on the bottle, broad spectrum. That's the official seal of approval that guarantees the formula has been tested and proven to protect you from the UVA rays too. Without it, you might be saving yourself from a sunburn, but you're leaving the door wide open for wrinkles and long-term DNA damage.
Okay, so you did your homework. You bought a great broad-spectrum sunscreen. You put it on this morning. You're all set for the day, right? And not so fast. The science is actually crystal clear on why reapplying is totally non-negotiable.
The reason has this sciencey name, photounstability. Remember our spongy bodyguards? Well, as they keep absorbing UV energy over and over again, some of them literally start to break down chemically. Think about a real sponge that gets so full and overused that it just starts to fall apart. That's exactly what's happening to their ability to protect you.
So what's the magic behind the every 2 hours rule? Well, it comes down to 3 big things. First, like we said, those chemical filters break down. Second, all sunscreens, even the mineral ones, just wear off from sweat and rubbing. And third, and this is a big one, most of us are only putting on about 1/4 to 1/2 of the amount we actually need to get the protection that's advertised on the bottle in the first place.
Now let's just zoom out for a second, because the chemistry of sunscreen doesn't stop at our skin. It actually has a much, much bigger impact.
It turns out that some specific chemical filters, mainly oxybenzone and octinoxate, have been linked to the bleaching of coral reefs. This has actually led to them being banned in places like Hawaii and Key West. And because of this, mineral-based sunscreens are now usually what people mean when they say reef safe, especially if you're going for a swim in the ocean.
And that really brings us right back to where we started. Sunscreen isn't just a cosmetic. It's not just for vacations, it's a daily scientific tool. Whether you pick a chemical sponge or a mineral shield, you are deploying a seriously sophisticated product that was designed for one main goal: to protect your actual DNA from being damaged. So really, the most important question isn't whether sunscreen is a mirror or a sponge. It's whether or not you're letting your molecular bodyguards do their job every single day.